The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example finding grams from coulombs. In a lead acid battery that we looked at in the previous lecture, right? How many grams of lead and lead oxide are consumed when the battery provides 700 amperes for 30 seconds? Wonderful. So how are we going to solve this problem? Well, first on this slide we'll find the amount of grams for the lead, and then on the succeeding slide we'll find the amount of grams for the lead oxide. All right. We will be taking a look at this reaction here. How are we going to do that? Well, we can just use our conversion map that we talked about. If we take a look here, we're looking for grams, right? And we have 700 amperes for 30 seconds. We're here and we're looking for grams, which is over here. That tells us that's going to be 1 conversion, 2 conversions, 3 conversions, 4 conversions, and such. And we don't even need to write down the numbers. We can just go ahead and just write down our conversions initially, and that's going to be, we said 1 conversion, 2 conversions, 3 conversions, and we'll do this one here just so we don't get crowded, right? 4, and that's going to give us our grams of lead. There we are. We're already set up, right? Perfect. First thing we need to do is we need to get into charge. Now, 700 amperes, right? What is an ampere equivalent to? Well, if you take a look here, an ampere will be coulomb per second, right? And because an ampere will be coulomb per second, then we can say that our 700 amperes is just 700 coulomb seconds. Now, we need to get into moles of electron. Well, 1 mole of electron, we just demonstrated on the previous slide, is going to be 9.65 times 10 to the 4 coulombs. Now we need to get moles. Well, for our lead here, let me just switch. For our lead here, right, per mole of lead, we have 2 moles of electrons. Thus, we can just go ahead and write per mole of lead, oh, that came out a little funny, per mole of, that is not wanting me to write lead. Okay, per mole of lead, it's going to be 2 moles of electrons. Wonderful. And then lastly, our last conversion here, it's always just going to be your molar mass. And if you recall, or you can take a look at your periodic table, and when you do so, you'll find that your molar mass for lead is going to be 207 grams per mole. Wonderful. And once you go ahead and you equate this, you will end up with 22.5 grams of lead. Yeah, and it's that easy. You don't need to make it more difficult than it needs to be. And as long as you follow your conversions, right, you're going to be fine. And then that gives you grams. Wonderful. Let's go ahead and solve the second part of this problem now on the next slide. Okay. Now we are looking for grams of lead oxide, right? In a lead acid battery, how many grams of lead oxide are consumed when the battery provides 700 amperes for 30 seconds? Well, here we're taking a look at the reaction of the cathode now. Okay. Well, how are we going to solve this problem? Well, we can just go ahead and take the exact same method, right? And we know that we will end up having 1, 2, 3, 4 conversions again. All right, let's begin here with 30 seconds that we're being given, right? And then we're going to have to make 1 conversion there. We'll make another one, and then we're going to have to make a third one, and then we're going to have to make our final conversion. Let me do this a little more for us to get into grams, right? And what is that going to give us? Well, that's going to give us our grams for our lead oxide. And there we are. For now, we have 700 amperes. 700 amperes, we just said, is equal to 700 Coulomb seconds, right? We have charge, now we need moles of electrons, right? And 1 mole of electrons is equivalent to 9.65 times 10 to the 4 coulombs. Now we're going to need moles. Well, let's take a look at our reaction. Per mole of our lead oxide, right, we're going to have 2 moles of electrons. Thus, we can just go ahead and write per mole of our lead oxide, we're going to have 2 moles of electrons. Wonderful. Now, if we, again, the last one is just going to be our molar mass here for lead oxide. And if you check it out on the periodic table, you'll find that it is 239.2 grams of lead oxide. All right. Wonderful. And when we go ahead and we equate this, we're going to end up with 26 grams of lead oxide. Thus, we will have 22.5 grams of lead, 26 grams of lead oxide are going to be consumed when the battery provides 700 amperes for 30 seconds. Okay, great. Let's now move on and we'll do another example, and this time we'll take a look at aqueous sodium chloride. And